Welcome to Archicraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dima Golodiuk at demongo.com.
You're listening to episode 14 of the podcast Archicraft. This episode is titled, How Do You Lead a Team Caught Between Overconfidence and Self-Doubt? In this episode, we explore the gap between what people think they know and what they actually know. We are examining the tension between overconfidence and self-doubt, the quiet forces shaping every engineering team. The talk is about how to build an engineering team where psychological safety is the bedrock and a given, helping to transform potential points of failure into opportunities for collective learning. Crucially, we discuss how to engineer a system where your best people are amplified, not silenced. A mature engineering culture is characterized by calibrated confidence and a commitment to intellectual humility, ensuring the best ideas win. Let's get started.
Ever led a technical team where, half the engineers seem wildly overconfident in their first ideas, maybe their initial designs?
Oh, yeah.
And then the other half, often the real experts, the ones with deep architectural knowledge, they're secretly convinced they're like one bad deployment away from being found out.
Totally. It's a classic dynamic. That tension, it's almost defining for high-stakes engineering teams, isn't it?
It really is. So today we're diving deep into Dima's guide. How do you lead a team caught between overconfidence and self-doubt?
Good one.
And our mission, well, it's pretty straightforward. We're not just going to define Dunning-Kruger, DK, and Impostor Syndrome, IS. We want to give engineering managers kind of a playbook.
Yeah, practical steps, how to turn that psychological friction, that chaos even, into actual measurable growth.
Exactly. Verifiable, scalable growth.
And I think what's really essential to grasp from Dima's thesis is that these aren't just, individual quirks scattered around the team. They are deeply linked. Two sides of the same coin, really miscalibrated self-perception. One group way overestimates their ability, and the other, often your most proven people, consistently underestimate theirs.
That's the paradox.
It is. And the guide really pushes this idea that fixing it means going beyond just one-on-one coaching. It needs systemic cultural changes.
With the manager stepping up.
Yes. Yeah. Stepping up as the chief calibrator. That's the term Dima uses.
I like that framing, chief calibrator. It treats this competence gap like an engineering problem itself. Something needing diagnostics, systemic fixes, not just, pep talks.
Precisely.
Okay, so let's start with the first type of miscalibration, Dunning-Kruger. The architecture of overconfidence.
Right, DK. It's that famous cognitive bias where folks who are less competent in a specific area genuinely overestimate how good they are at it.
Yeah.
And it's key to get this. It's not about low general intelligence. It's very domain specific. Dunning-Kruger called it the dual burden.
The dual burden.
Yeah, because first, they lack the necessary skill. But second, that same lack of skill stops them from having the metacognitive ability to even recognize their own incompetence.
So they lack the framework to judge themselves.
Exactly. They don't know enough to know how much they don't know.
And we see this play out on the typical engineering learning curve, right?
Yeah.
What happens when that junior engineer starts feeling, like they're getting the hang of things?
They hit what the source calls the peak of Mount Stupid.
Right. Less slightly Mount Stupid.
Yeah. It's that state of unconscious incompetence. They've maybe finished a boot camp, landed a few PRs, learned enough basic syntax to feel functional.
Feel productive.
Feel productive, exactly.
Yeah.
But they are blissfully unaware of the crucial complexities lurking underneath. Things like, performance implications of their database queries, security holes, scalability, tech debt.
All the hard stuff.
All the really hard stuff. Their confidence is sky high because their awareness of the vast unknown is basically zero.
That makes perfect sense.
Yeah.
If you don't even know that network latency is a thing, you're not going to worry about it in your design.
Yeah.
You just assume your simple approach works everywhere.
Spot on. And this is where the manager or the team culture becomes critical. If there aren't rigorous code reviews or good mentorship, their code might just superficially work.
Yeah, it passes the basic test.
Passes the tests, and that just reinforces their inflated self-assessment. They get stuck up there on the peak.
Okay, so what pushes them off? What triggers that slide down into what the sources call the valley of despair? Sounds painful, but maybe necessary.
It's often painful, yeah, but it is the necessary calibration moment. It's usually triggered by, say, a really nasty bug in production that was their fault.
Ouch.
Or a project failing because the complexity wasn't understood. Or maybe just a really thorough code review from a senior dev that just rips their assumptions apart, showing the true scale of what they need to learn.
The humbling.
The humbling, exactly. The engineer suddenly realizes, wow, I actually know almost nothing about this. They shift to conscious incompetence. Confidence plummets.
But that's the start of real learning.
That's the absolute prerequisite for deep, sustained learning.
Yeah.
You have to know you don't know before you can truly learn.
Okay, so while the DK person suffers from a lack of awareness, the imposter syndrome sufferer, they have almost an excess of awareness, right? Let's pivot to that side. The paradox of proven competence.
Yeah, imposter syndrome, or IS, this tends to affect high-achieving folks, people who have loads of objective, external proof they're good promotions, successful projects, positive feedback, but they just can't internalize it. They live with this persistent fear of being exposed as a fraud.
They explain away their successes.
Constantly. It's always external factors. Oh, I got lucky, or the timing was just right, or, well, I worked way harder than anyone else. It's never attributed to their actual skill or intelligence.
And engineering, tech in general, seems like such fertile ground for IS, I guess because of the sheer speed of change.
Absolutely. You ship something amazing using, I don't know, Rust 1 month.
Yeah.
And the next month, everyone's buzzing about some new framework you've literally never even heard of. There is always a massive amount you don't know.
You constantly feel behind.
Constantly aware of a vast, expanding frontier of ignorance. And the more senior you get, the more you know, paradoxically, the more you become aware of how much you don't know. It just feeds that IS narrative.
Right. The sources mention a few archetypes we see on teams.
Yeah, these can be helpful to spot. Take the fellowist.
Okay.
This is the engineer who thinks, deep down, that true competence means figuring everything out alone. Asking for help feels like admitting they're a fraud.
So they don't collaborate well.
Terribly. They might avoid version control best practices, definitely won't write docs, might hoard knowledge about a critical system. It's all about protecting that fragile sense of self-reliance, creates huge bus factors and tech debt.
And then there's the other type, the perfectionist, or superhero.
Yeah, the superhero or perfectionist. They believe they have to work longer, harder, and deliver absolutely flawless code first time, every time.
Wow, impossible standard.
Totally unsustainable. Any tiny bug, any change in requirements isn't just a normal part of software development to them. It's crushing proof of their inadequacy. Leads to paralysis or burnout.
Yeah, I can see that. And you mentioned this often gets worse when people move into senior roles.
Oh, that transition is a potent trigger. Think about it.
Yeah.
You go from short, clear feedback loops like, does my code pass the tests? Did the feature ship?
Right, very concrete.
Very concrete, very objective, to long, much more subjective feedback loops like, was my architectural decision good? Am I mentoring this junior engineer effectively?
Takes months, maybe years to know for sure.
Exactly. That lack of immediate objective validation creates this perfect storm of uncertainty. And the IS sufferer fills that vacuum with their internal narrative of self-doubt.
Which leads us right into the toxic interplay on a team. You've got the overconfident novices, the GK folks, often dominating discussions.
Yeah, they tend to be assertive, maybe louder.
And the self-doubting experts, the IS folks, they tend to withdraw, right? They undervalue what they know.
They do. They defer to the louder voices, even when they have serious reservations, maybe even know a decision is flawed.
So the result is decisions get made based on the confidence level of the speaker, not their actual expertise.
And the team gets robbed of its most valuable wisdom. It's incredibly dangerous organizationally. The chief calibrator, the manager, needs to see this pattern and understand the different kinds of risk involved.
Okay, so we're talking about risks of commission versus risks of omission.
That's a really key distinction Dima makes, yeah. The DK engineer introduces the risk of commission. They actively do things but the wrong things.
Like committing to a bad design.
Exactly. Committing to flawed designs, giving totally unrealistic estimates because they just don't see the hidden complexity, merging buggy or untested code. They're doing stuff, but it's often damaging.
Yeah, the IS engineer. That's the risk of omission.
Precisely. It's the risk of not doing things. It's the stifled innovation because they were afraid to suggest a bold idea. It's the critical flaw in a plan they saw but didn't speak up about.
Or the best practices that never get shared because the expert felt too insecure.
Right. It's the silence that can be incredibly costly. It's the loss of potential.
So how does a manager tell them apart? Especially when maybe someone is just having a bad day.
Dima suggests looking at how they react to failure. It's quite telling. Observe what happens after, say, a significant production issue.
Okay.
The person leaning towards DK will almost always externalize blame. Well, their requirements were unclear, or QA should have caught this, or that other service went down. It's always something else.
Not their fault.
Never fundamentally their fault. The person struggling with IS, though, they do the opposite. They internalize blame excessively. They see the bug not just as a mistake, but as proof of their deep personal inadequacy, a character flaw.
Wow, okay. That's a clear diagnostic. That obviously informs how you intervene.
Absolutely. Which brings us to the manager's playbook. If calibration is the goal, what's the foundation? What's the bedrock strategy?
It has to be psychological safety, right?
Absolutely. Number one, you can't even begin to address issues of self-perception over or under confidence if people are afraid. Afraid that admitting ignorance, making a mistake, or showing vulnerability will lead to blame or punishment.
So the manager has to set the tone.
Critically, they have to model vulnerability themselves, admit when they don't know something, talk openly about mistakes they've made or strategic decisions that didn't pan out, make it normal.
The sources really highlight blameless postmortems as a key ritual here. How does that specifically help with both DK and IS in an engineering context?
It's powerful because a truly blameless postmortem shifts the focus entirely from who messed up to what in the system allowed the mistake to happen.
Systemic causes.
Exactly. What went wrong with the monitoring? Was the deployment process flawed? Did we lack the right automated tests? Is the on-call rotation burning people out? For the IS engineer, this is crucial. It decouples the error from their identity. Failure becomes a collective learning opportunity, not personal shame.
And for the DK engineer?
It forces them to confront the actual systemic complexity they probably glossed over in their overconfident, simplified view. They can't just blame bad requirements when the whole team is dissecting the failures in the release pipeline. It's calibration through system analysis.
Okay, so safety first. Then, with that foundation, we can move to more tactical interventions, like structured feedback, designed to cut through those subjective biases.
Right. Because both DK and IS involve a distortion of reality, you need feedback grounded in objective data. This is where the situation behavior impact SBI model becomes so valuable.
Yeah.
It forces everyone, the manager giving the feedback, the person receiving it, to stick to the facts. No judgment, just here's what happened, here's what you did, here's what resulted.
So for the Dunning-Kruger engineer, you use SBI to gently confront their overestimation.
Exactly. You're holding up a mirror based on evidence. You wouldn't say, you were way too optimistic again. That's judgmental.
Right.
Instead, using SBI, during sprint planning last Monday situation, your estimate for rewriting the authentication module was 2 days behavior. Because that task actually took the full 2-week sprint to complete impact, the downstream features X and Y were blocked and missed the release.
Facts. Direct, data-driven, non-emotional. It forces them to reconcile their estimate with the actual outcome.
Precisely. And then you can have a constructive conversation about why the estimate was off. Now, how do we flip SBI for the imposter syndrome engineer? They need reinforcement, right?
Yeah, they need evidence against their internal fraud narrative.
So you use SBI to provide specific, concrete proof that their successes are due to their competence, not just luck or brute force. You need to highlight the high-impact contributions they tend to dismiss.
Give me an example for IS.
Okay, instead of just great job in the meeting, you'd say, when you presented your analysis of the load balancer performance behavior in yesterday's architecture review situation, it gave us the specific data needed to identify the bottleneck, which directly led to the fix that improved latency by 30% impact.
Ah, very specific. It links their action directly to a positive, measurable outcome. Harder to attribute that to just luck.
Much harder. That concrete evidence acts as a counter-narrative to the internal, I'm just faking it voice.
Okay, so individual feedback is key. But Dima's guide also stresses more systemic validation channels.
I thought the idea of using mentorship against imposter syndrome was really clever.
It is, isn't it? It's like a mechanism for forced self-calibration. You take senior engineers who often wrestle with IS,
Right.
and you task them with mentoring junior folks. That very act of teaching, of explaining complex concepts, maybe breaking down distributed tracing or reviewing code and seeing familiar early career mistakes, it provides this undeniable, tangible reinforcement of their own expertise. They have to articulate what they know, which makes them realize how much they know.
Exactly. If they see their knowledge reflected in their mentee's growth, it bypasses the internal critic because the evidence is right there in front of them.
Makes sense. And the final piece of the systemic puzzle, clear public career ladders. How do they help?
They act as that crucial external institutional validation. That's often what someone with IS really needs, something outside their own head confirming their competence.
So it's not just their manager saying they're good, it's the organization.
Right. When you have well-defined ladders spelling out the skills, scope, and impact expected for, say, a senior engineer versus a staff engineer versus a principal, it demystifies career progression. It provides an objective, impartial benchmark. When the company formally says you meet the criteria for L6 staff engineer because you successfully led the platform migration project, it's much harder for the individual to cling to the "I just got lucky" narrative.
It's an institutional counterweight to the internal doubt.
Perfectly put, an institutional check.
So pulling it all together, it seems the most effective leadership here goes way beyond just dealing with individual symptoms. It's about being an organizational architect, isn't it? Building these systems, safety, feedback, validation, that constantly, almost automatically help calibrate self-perception across the team.
That's the core idea. And the ultimate goal really is to cultivate a culture of intellectual humility.
Intellectual humility, meaning
Meaning the team culture actively rewards not just the person with the loudest right answer, but the people who ask the really insightful questions, the ones who constructively challenge assumptions, who readily admit when they don't know something or when they made a mistake.
because that's how you tap into the collective intelligence of the team, not just the confidence of a few.
Exactly. That's how you optimize for the best ideas winning, regardless of who they came from.
Which requires, and this sounds like the hardest part, separating the value of an idea from the volume or the confidence or the identity of the person proposing it.
Yeah.
That's the ultimate calibration challenge.
It truly is.
So let's leave our listeners with a final provocative thought to take away. Thinking about your own team, your own meetings, how could you deliberately structure your next technical design review? I mean, the actual format, the process to ensure that the quietest, maybe most hesitant, but potentially most valuable idea is the one that actually gets heard and wins out.
Thanks for tuning in to Archicraft. This episode was generated using AI from Dmitro Golodiuk's blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.